Hello, you're watching Kalike, and I've come up with another numerical on Newton's laws of motion. So let's see what the numerical says. A constant force acting on a body of mass 3 kg changes its speed from 2 meter per second to 3.5 meter per second in 25 seconds. The direction of motion of the body remains unchanged. What is the magnitude and direction of force? So this looks pretty simple and straightforward. So most of the quantities are known, right? So let's first write them down to know what is unknown so that we can find that out. Okay. Now it says a constant force is acting on a body of mass 3 kg. So F is constant. So F is unknown, in fact, that is what you have to find out. F is not known, so constant force. The force is constant, it's not a variable force, and the mass is 3 kg. Okay, that's given. And then its speed is changing from 2 to 3.5. So this becomes the initial speed, this becomes the final speed. So V0 is 2 meter per second. And then you have V is equal to how much? 3.5 meter per second. And all that happens in just 25 seconds. So the constant force is applied for 25 seconds, and then you see this is the change that is happening. So that means it is certainly undergoing an acceleration which is not given, right? Because there's an increase in speed, you see. So if there's an increase in speed, it's definitely undergoing an acceleration. So which means you will have to find out the acceleration in order to find out the force experienced by the body. It says that the direction of motion of the body remains unchanged, which means the body continues to move in the same direction. So obviously this direction would remain the same, but anyhow, let's find out more. So I have V0 T. I can easily calculate A. If I calculate A from Newton's second law of motion, since it's a constant force, I can just use F is equal to m into A. Mass is given. If I know the acceleration, I can calculate the force. So very simple numerical. So let's just do it. V is equal to V0 plus A into T. V is 3.5, which is given. V0 is 2. A is not known. That is what we have to find out. And T is 25. So if I bring it on the left hand side, so it will be 3.5 minus 2.0 is equal to 25 times A. So let's subtract 3.5, 2.0. So if you subtract, you have 5, and this is 1.5. So you have 1.5 is equal to 25 times A. So how do you find out A? A will be equal to 1.5 divided by 25. So what do you do when you have a decimal after single digit? Multiply the numerator and denominator by 10 to eliminate the decimal. So this becomes 150 divided by 250, right? So therefore keep the decimal point back after one digit. So this will be 15 divided by 250, right? So this can be easily simplified. You can even simplify it like this. Let's say 5 3s are 5 5s are. So this is A is equal to 3 divided by 50. So I have to divide this. I will divide it here. So you have 50 in the denominator and 3. So I'll keep a decimal point, borrow 0. That's not enough. So you have to borrow another 0 and make it 300, right? Now 56 becomes 300. So therefore acceleration would then be 0.06 meter per second square. So it's very simple. You find out the acceleration. Now it's very easy to find out the force, because that is given by m into A by Newton's second law of motion. Mass was given to be 3 kilos. 3 into 0.06, 3 6 18. So you can write it as 18, and then you have to keep a decimal point after 2 digits, so it becomes 0.8 Newton, right? Because you have to keep the decimal point after 2 digits. So I'm keeping it after 2 digits. So this is the magnitude of the force experienced by the body. Now since the numerical says that there has not been any change in direction, this implies it is in the direction of force. So the direction is unchanged. There's no change in direction. And this, the acceleration is acting in the direction of force. Right? So this is how you solve numericals on Newton's second law of motion. Let me know if you have any doubts in the comment section. Subscribe to our channel and click on the bell icon. Thank you.